Hi. So today we are going to be looking at how to make this thing. It's basically a bunch of walkers. They're sort of going in between a bunch of different objects, and yeah, it has this nice sort of symbiote alien type of vibe to it. And it's completely generative, so you can put in whatever shapes. You can increase the number of walkers that you have. So in this case, yeah, a whole bunch of walkers, 33 walkers to be exact. And yeah, it's pretty simple. No GLSL required. Um, let's just get straight into it, I guess. Okay, so some basic concepts that we might want to get out of the way before we start to actually build what it is that we're making. Let's just see how we kind of make this in the first place, right? So I've opened up Paint for me to draw like a super professional explainer video, or an explainer thingy. Um, and so just for the sake of imagining, let's imagine we have some solid object. Let's assume that this is 3D space. That's X, Y, and Z. X, Y, Z, or X, Y, Z. Right? Let's say we've got something in 3D space. This is a 3D object, right? And so the step one, what we're essentially going to do is after we place the 3D object, we instance a bunch of curves, small little hair-like thingies um, on basically this 3D object. Um, we place a bunch of these around, and you have control over how many you want to place, and that affects the visuals itself. Right? So once we've essentially placed them on this 3D object, what we will then be doing is defining a point. Again, in 3D space, right? Just defining a point. And how we'll be sort of using that point is we'll be using that point essentially to drag all of these curves into itself, right? Right? So, and if you see, we're already kind of getting that mimic, we're kind of mimicking that effect already just by sort of drawing it out and thinking about it logically. Uh, but you'll notice that if we place this point, we don't want the points that are further away to sort of be affected. Uh, we don't want this one, for example. For example, let's say there's another point over here, another thing that you want it to grow to. You don't want this to come and sort of connect to this point number one. You want it to go and connect to point number two. So we'll be essentially building the logic gate and the system to sort of understand which one of these curves sort of will scale to which respective point, right? So yeah, that's pretty much it. So this is one mimic, this is a second one, and this is a third organism, right? And then just another last bit of logic that we need to approach is what if this organism goes from here to say somewhere over here? What do we do in that case? Well, in that case, what we want to do is say break off. We want to break these off. We do not want these lines anymore, so we will be deleting these lines. And basically, the lines that are still relatively close are the ones that we will sort of be drawing. So we've deleted these lines and we'll be adding new lines, right? So yeah, this has turned out to be one of the worst diagrams. But I hope you sort of get it. If you really want to kind of understand the workflow and, how to sort of, the core logic, this was actually borrowed from this video by Cartesian Caramel from a long time ago. This is from like 3 years ago, which is like ancient in just tech wise, and it's on Blender 3.2. Um, so yeah, pretty much just dragging this into Pops. And one thing to remember is that Pops actually works very similarly to geometry nodes. So there's a lot of stuff that you could actually end up sort of taking from geometry nodes into Pops. And there's like a whole bunch of tutorials on different things that you can do. Cool. So let's just quickly get started with whatever it is that we're trying to build. So the first thing that we're going to do is actually drop the object that we will be using to instance our points on, or to be instancing our curves onto. So this is going to be the object that I'm going to use. Uh, After that, we're going to add a sprinkle node, right? So sprinkle node, as it suggests, sprinkles a bunch of points onto the object. Let's just bring that down to something a little bit less, maybe 1,000 for now. Right. Now that we've added these points in, we actually need to instance all of our curves. So let's start off by first making our curves in the first place, right? So I'm going to drop in a line, and I'm going to say position 0 is at 0, 0, 1, right? If you're following this, then make sure that it's position 0 is 0, 0, 1. If you sort of swap things around a little bit later, you could change this to 0, 0, 1 instead of the top one. But for now, I would suggest just keep it this way. So we've got 0, 0, 1 over here. And let's just add a little bit of variation. So this one's now pointing in that direction, and let's just say this is minus 0.2, right? And that one's pointing in that direction. And now if we merge them all together, like that, what we should get is something like this, right? So this is essentially what we will be instancing onto every single one of these points over there. But prior to doing that, we also need to set up something else. We need to set up the points that everything sort of the lines all collapse into, right? So for now, I'm just going to say that it's a point generator, and let's just take it down to 5 for now. We're going to essentially have 5 points that everything sort of collapses into. So we'll have 5 walkers. This point gen over here is essentially what will control the number of walkers we have in the first place. Right? So we've got point gen, and we've got 5 of them over here. After the point gen, let's just put a null so that we can swap it out with something else if required. After this, what you want to do is use the neighbor pop. And the neighbor pop essentially gives you a bunch of really useful data. So we're going to put our sort of the collapsing points into input 2 and sprinkle into input 1. And again, just put a null right behind that. Yeah, and this one in neighbor pop, there are a few changes that we have to make. So distribution needs to go to closest, because we are looking at the closest point from like each one of these points, each one of these sprinkled points. Which one of these points is the closest to any of these points, basically, is what we need. Yeah, distribution will be closest. Let's just change the max neighbor distance to 1,000 because we want it to be checking for like large values as well. Num neighbors, well, our max neighbors is going to be 1. We're not going to have any more than 1 because we are looking for just the closest. So essentially we don't need num neighbors anymore. We turn on dist, call it dist itself, and our neighbor point attributes that we want to also pass on will be neighbor p. So let's just quickly look at the pop2 dat in this and sort of understand what is sort of going on over here. So if we look at this, what you'll sort of notice is, what we'll notice is, let's just copy this and put this one in here so we can check the differences between each. So over here in the sprinkle node, we only have the position data, the normal data, and the texture data, right? If we come into the neighbor pop now, if we look at the pop2 dat of the neighbor pop, we will see that we've got the position data, we have the distance data. We also have which one of these points we are closest to. So the distance from point number 2, right, which is probably one of these. I have, let's just quickly take a look. Display attribute text point indices, right? So this is point number 0, this is point number 1, 2, 3, 4. What this is doing is essentially point number 0 over here. So do the same thing over here. Point indices. Well, so there's a point 0 somewhere in here. There's a 3 over there. So let's just take the 3, right? There's 3. Let's just look at 3. Let's just look at index number 3. What this is essentially saying is that the distance of point number 3, which is the one we identified over here, the distance of point number 3 from neighbor 2, which is essentially what we found over here. So that's the closest point to point number 3, apparently, is whatever is there in distance. It's whatever is there in distance. And the reason distance is within these brackets over here is because we can actually look for more than one neighbor. So if I set this to 2, for example, or 3, you will see this 0, 1, and 2. So you've got 3 different neighbors, but we just want 1 for now. So distance 0 is what we'll be using. Cool. We're done with that. We now essentially come back up here and drop something called the line metrics pop. Line metrics, essentially what this does is gives you a bunch of information about this spline over here. So the information that we need to pass on at this moment is distance from start normalized, the tangent, which we can use for like colors and stuff like that. And that's actually pretty much it. I don't think we need to send any other data. Cool. So now let's drop in a copy pop. Drag this in here and drag this in here. And this is what you're going to get. You're going to get a whole bunch of points. Basically what is happening is this, perhaps few too many points, but this thing, each one, like these roots that we see over here, we're placing one root at every point. So this gets one root, this gets one root, this gets another root, this gets another root, and we're just placing them like that. So that is pretty much what we've made over here. So we're done with instancing our roots. Now we need to figure out how to bring or how to collapse all of our roots into these points over here, depending on how far those points are. So post this, what I'm going to put in is a curve, and I'll explain why we're going to put in a curve, but for now, just bear with me. We're going to be using a curve type of a Bezier, and the values that I found to work are alpha 1, alpha minus 1, and beta 1, right? Those are the values that I found to sort of work. You can play around with these to get sort of nicer values. Actually, I think it was alpha 1 and beta minus 1. But just play around with these values and see which works. You want to come in here and use apply lookup, and you want to use your distance start norm as your lookup index. Your output attribute scope is going to be something called falloff. And this falloff is what we will use to sort of set how our curves interpolate between the collapsing point and the point on the object itself, right? So let's actually do that. And over here, we'll be using a math mix. So first things first, we are going to do A minus B what we're essentially going to be doing is say, uh, oh, my bad, sorry. Before we move on, there are a few things that we need to do over here in the copy pub. We need to be transferring a few of the attributes that we have from here into the copy pub, right? If you look at this, we only have these attributes. So let's just quickly add them in. The three attributes that we're essentially going to be copying, which is going to be distance, uh, neighbor, and neighbor position, right? Um, I'm going to quickly just rename neighbor position perhaps, but we'll do that later, I guess. Um, so these are the points that are sort of being sent in. Uh, so what we want to do in this math mix is we want to say P, our first value is P, and we're going to be subtracting that with the neighbor position, which is essentially uh, these positions. So what we're doing basically is moving every single one of these points to where, so you'll notice that there are 5 places basically where these things are sort of moved to. You've got 5 clusters. You've got one here, one here. Essentially, the 5 clusters, what is happening is that it is offsetting uh, each one of these by this amount over here, right? So that's doing something right now, right? Suppose that we want to also add in our fall-off. So for that, we're going to do a into b, which should be somewhere in here, into b, right? So we're going to say p times fall off, right? And that fall off is exactly what is sort of placing these things in their respective positions. So we will be playing around with these fall offs to get, more appropriate and nice values. But for now, let's just leave it at that. Um, the next thing we want to do is actually move these points back to their original positions, right? I mean, if you've noticed, they've all been offset. The offset was put so that we could manage the falloff. So we're going to do an A plus B, which is essentially reversing what is happening here, and neighbor P. And if you now check, that's actually pretty cool, right? So these are apparently all the different points where this thing spawns from. So just to check if this works, changing the seed should ideally change how this thing works, right? Uh, just to check on how the fall off stuff works as well. Yeah, these are the values that I was using, -1 and 1, and definitely play around with these a little bit more to sort of, um, you know, get things to your liking. Also normalize the U, just in case, because you don't want things to be going sort of haywire either, right? Um, Too many points, so maybe I've just decreased the number of points for it to be a little more cogent. So this is what it looks like with just 62 points, right? All right, cool. So now we've done the part where things are collapsing. What we have to do now is add in a few noises just to give it a slightly more organic feeling. The problem with adding the noise is that it is changing not only the positions of our of every single point and adding a little bit of a noise to everything, it's also changing our origin locations. It's adding noise right now to every single position, including this is supposed to stay on our grid, on this grid, but it's clearly not, because the grid is on the x y plane, and this is clearly not on the XY plane. So prior to doing that, let's quickly put in a lookup texture. We'll put in a ramp, and basically what we want in the ramp is white and black. Oh, oops. We want white here and black here. And I'll just explain to you in a moment why we want that, right? The lookup index attributes that we actually want will be um, distance start norm, right? Uh, just I don't know if we have to do it for everything. I don't think we do. Uh, But yeah, and then essentially we can call this output attribute, we can call rampa, and really we just need the R value, we just need a single value, so we're gonna just mask out the other values for now. Right? So essentially once we come in here, if we go to map, we can say rampa, we can say then map this to amplitude, and set this to multiply. And now you'll notice that all of our points are back on the XY plane. So we're back in business. Cool. Just add in your noises the way that you want. So the way that I usually do it is I add a sort of like a high period noise, add a little bit of variation, amps time about seconds times 0.2. And over there, just to kind of make it move around just a tad bit. And then what I sort of do is the same thing, Control C, just copy that, Control C, Control V, put that in here, put that in here, and just change the seed, increase the harmonics, and play around with the amplitude a little bit, maybe try to get some cooler looking stuff. And I like that. That's good. That's nice. Right? That's nice. And you'll notice that if we move these guys around, uh, like say, yeah, stuff starts to happen. So we're getting close. Right? We're done with this bit. Let's just add a null after this. Now we're going into the deleting logic for this. So the way that the deleting logic would work is actually basically we want to delete the points that are far away from the collapsing points, right? Points that are far away from, oops, yeah, points that are far away from here, we want to delete those points. And we don't want to just delete them randomly. We want to delete them in a way that it looks like it's actually sort of happening along these lines, so it looks like these lines are sort of emanating from a certain space. So first thing we do is rearrange. Right? What we'll be rearranging is distance, single array. And we're going to just be calling this inv dist, right? So this is inverse distance. And the reason it's inverse distance is because we will be changing the distance values from 0 to 1 to 1 to 0 over here, right? The next thing that we want to do is a math mix, right? This is going to be where we delete our points. So what we want to be deleting our points from is the inverse distance minus our distance start norm, right? And I'll just explain that to you in a bit while we're doing that, but we'll call this del word del, right, for now. Cool. Now all we have to do is put in our delete pop in there, like that. Delete selected, all of this stuff, delete pointer and delete line strip. Okay. And so we need an attribute. Our attribute will be word delete. And there you go. We've already gotten somewhere. So over here, we're using the lesser than sort of operator to get this. And as you decrease this value, it sort of grows more and more. The cool thing is that if you don't need to just do that, it will by itself map. Yeah, so for example, if it's close, you will see that these points are getting completed, but these are not, right? And that is what gives it that walking effect, right? So, yeah, we are pretty much done at this point. We just need to add a few colors and actually merge the grid to check if what we're doing is right in the first place. So, yeah, I'm going to just put a geo right after this so that we can see it in our camera. And I'm going to put a null after this. And then from this null, a geo. Right. And then once we've got our camera, render, top, and let's just throw in a light as well, just for the heck of it, and turn on shadows. Right, there you go. We already have something happening. Right, change the shadow softness if you wish to, light size, light height, all of these things. Right, uh, yeah, but let's just quickly take a look at whether things are working the way we expected to. So I'm going to angle this a little bit differently. Right. So the problem right now is that our first point is actually down there, right? So things are collapsing into this point over here, and they're not really moving around. So let's quickly make things move around by just adding a noise and saying abs time dot seconds times 0.2, and there you go. Just simply by doing just that, you should see this Walker effect. Now, if you want to reduce the levels, the reasons why reason why things aren't getting instanced, like these points aren't sort of coming onto the underside of this plane, is because the normals or the sprinkles aren't over there, so to speak. So if I were to replace that with a sphere or something like that, you know, should get something a little bit different. Yeah, you should get something that looks sort of like that. Uh, Cool. So that's that. That's that. And once let's play around with the seed, I guess. Some of these seeds are a little lame. Let's increase the size of these. There you go. And let's just, I just taking chances here again to give me something. There you go. This looks nice. And and the more I sort of increase the noise value on this, the more these guys will walk around and the more you'll see them sort of try to reach out. There is obviously a sweet spot with this, you know, point 0.1 minus 0.1 minus 1 sort of looks nice, but really it depends on the shape and the size and everything of whatever it is that you've done. So but yeah, this is what this looks like. I think it looks pretty cool. Now, one last bit to go over, and that is how do we color these? To color this, it's pretty simple. For now, let's just use a noise to color this, right? Um, it's adding noise in terms of position right now. That's not what we want. What we want is to change this output to color.rgb, and it's giving us something for sure. Uh, you want to add the curl noise, you don't want to add just normal noise. And this you will change to neighbor. Oops. My bad. So this will be neighbor 0, right? And yeah, you should then, once you increase the amplitude on this, you should be able to see that all of these guys have their own sort of distinct uh, colors that they sort of work with. This last walker is annoying me a little bit, so let me just transform this guy and cheat a little bit maybe. Uh, that's not it. It's probably Z. There you go. Yeah. Anyways, we don't have to do that right now. Uh, just, just right. So that's cool. That's nice. We have different colors for all of these things. Um, and changing the seed will give us different colors for that stuff as well, right? Um, the materials, I really wish, like Blender has something called a curved mesh node. Pops doesn't really have that. The closest thing that I could find was something called the revolve node, but it doesn't do what I want really. Uh, yeah, it looks cool. It looks interesting, but again, like doesn't do what I want. It just does its own thing, really. And while it's cool, um, it's not what I want it to do. So, um, all right. So, whatever you do not do what I just did because it just crashed. Um, yeah, I would not recommend using the revolve node because it doesn't do what I want it to do, really. That's the main issue. So let's not use the revolve node. Instead, what I found is that the wireframe node actually does a very good job. So just running you through how I sort of use the wireframe node, I drop in um, the wireframe node. I reduce the alpha value on this, which I find to be quite important because it gives me a little bit more sort of, um, you know, um, yeah, I get to see the stuff behind as well, as opposed to just the ones on top. And then I can play around with the line width and stuff like that over here. And each thing has its own sort of unique, cool thing going on its own. Um, but yeah, it's pretty cool. If I increase the number of yeah, so now it just looks like a bunch of piece of paper just flying around, and uh, yeah, there's some whack stuff going on. This may be a bit too much, uh, but yeah, essentially that's the process. Um, I will be like, there should be a talks down below, which essentially just allows you to just drop in uh, the different, the point generator and like the objects you want to sort of instance onto. It should just drop that in automatically. Um, and yeah, the that you can sort of pay me a little bit of money and just get the talks because I need to feed myself. I'm not sure. Yeah, Patreon doesn't work in India, so it's not going to be Patreon. But you'll find it down in the description. Um, but yeah, that was my first ever touch designer tutorial, like my full-on first ever touch designer tutorial. I hope you liked it. Credit to Cartesian Caramel again. This method was, it's quite old. I'm pretty sure they use it a lot in a lot of different places. Uh, but yeah, thanks to Cartesian Caramel for figuring this out a long time ago. That's kind of where I got inspired from. And yeah, hope to see you around. I'll be hoping to do a lot more of these. And uh, please do leave a like or whatever, I don't know, it is that happens in this YouTube world. Check out more of my work. It's on my Instagram. You'll see some of my stuff on YouTube. I am turning this into a more proper thing at this moment. But yeah, thanks. Thanks for tuning in. Bye bye. See you.